Good evening and welcome back, students. Very important topic is coming. We have already discussed with you nomenclature, how to write the IUPAC names, how to write the IUPAC name. We have discussed with you, students. That is a very important question for the coming papers. How to write the IUPAC name, right? We know about that rules. The rules are known to us. How do we write the IUPAC name? Yes or no? Tell me fast. Do we know that?
Yes, sir.
Okay. For example, one or two questions. Supposing you are given in the paper, write the IUPAC name. This is a compound, student, NiCl4 2 minus. What will be the name of this compound, student? This is a very simple. You are given NiCl4 2 minus. You have to write the IUPAC name of this complex, student. So what rules we have told you, student? Apply them. What will be the name of this compound? You will get only 1 minute for answering a question before we go to the next topic.
Yes,
Just
sir.
to make some revision, some recap, student, how we will write the IUPAC name, because a question is coming in the paper. This one is a very simple compound which we gave you, student. This is a bracket here. What are the rules which we told you? We have to apply the rules, that's all, students. Write the proper chemical name of the following coordination compounds. What is
Hmm.
type of complex is this? Cation, anion, or neutral? What type of this? This is a complex ion. This is a complex ion, student. What is this? This is the simplest case we have given you. This has a negative charge. What is this then? This is a complex anion.
Yes, sir.
Then what are the rules for that? We have told you. What is a ligand? Ligand is here. The ligand is, which ligand is there? Cl minus. It is an anionic ligand. Then what is the name of the Cl minus in the IUPAC name? Chlorido.
Yes, sir.
How many are there? Four. Four. Then what is the problem here? This becomes tetra chlorido. Now this is an anionic complex. What is the oxidation number of nickel here? What is the oxidation number of nickel? We have to calculate. What is the oxidation number of nickel here, student? Oxidation state of nickel. If I put it X, then this is minus 1 into 4 equal to minus 2. Then what will be the value of X? That will come to be plus 2. So the oxidation number of nickel is plus 2. Then what is the name of the nickel in this? It is an anionic complex. What
Yes, sir.
formula we told you for anionic complex? What will you write? Nickel or nickelate?
Sir, it will be Nicolate. NiClelate.
Nickelate. And how many? 2. How do you write 2, student? Iron. That's all. See, we have to do some questions, student. Then only we know what we are doing. If I have another question, student, this question number 1, question number 2. This complex is given PTNS3 twice Cl4, student. Then this is enclosed. How will we write the IUPAC name of this
Yes, sir.
compound, students? How to write the IUPAC name? This is a neutral. This is a neutral complex, student. There is no charge on the top of this. Do you see any charge
Mm-hmm.
here? Nothing. Any counter ion?
No,
Nothing.
sir.
Neutral. What are the ligands? What are the ligands? NH3. What do you call NH3 as? Amine. And you have
Yes, sir.
Cl4, Cl minus. That is chlorido, because it is anionic ligand. Anionic ligand. How many are these? These are 2. So it will be di. How many are these? 4. Then it will be tetra. What is the oxidation number of platinum here? We have to calculate the oxidation number of platinum, students. What will be the value of that? Oxidation number of platinum. How much will it come? X.
Hmm.
This is what? 0. NH3 is neutral. This is neutral ligand. 0 into 2. And Cl4, how much? -1 each. So you have -1 into 4 equal to 0. So what is the value of X then? What is the oxidation number of platinum in this case, student? Platinum is in which oxidation state? 4. What is the value? X will be +4. Neutral complex. Which will be named first? Amine or A or C? Alphabetically.
A, sir.
What will be the then IUPAC name of this compound? In the exam, what I will write? Diamine. That's a double M here. Then tetra chlorido. Now what will I write for platinum? What will I write for platinum now? Tell me. Okay, this you have noted. What will I write then for platinum? Is a neutral complex. In neutral complex, the name of the metal remains the same. So what will I write? Platinum. What is the oxidation state of the platinum, student? 4. Roman letter. That's all. This is the name of this compound, student. This is the IUPAC name of this compound. Any doubt? Tell me, any doubt is there, student? Any doubt is there? Tell me. What will be the name of this compound? Are you listening to me? Any doubt? Okay. Now, if I have to name this compound, this is very important. How do I name it? First, I should find out whether it's a cationic complex or an ionic complex. What will I do in the exam, student? I will write it like this: PTNH3 twice Cl2, students. Then it will become, this is 2 plus charge. This is 2Cl minus. So it is a cationic complex. This is a cationic complex ion. Cationic complex ion. Then you have diamine dichlorido. What will be the name of this? Diamine dichlorido, an ionic complex. Platinum is in which oxidation state here, student? If I put X for this, X plus 0 minus 2 is equal to plus 2. Therefore, X is equal to plus 4. Platinum is in plus 4. This is a cationic complex. The name will remain as such. Platinum 4. And last one, you have Cl2, you will write chloride. Bus. This is how we write the IUPAC names of these compound, students. So here is some of the questions which are now homework, which you can do later on. And you can try to do these questions, students. We have just tried to show you few examples again for the exam. How do we write the IUPAC name? Very important, very important. So I hope we can write the IUPAC name, student. This is one question will be there. And this is, we are saying homework for you, student. You can try it later. Write the IUPAC names of the following compounds. Okay. Then we proceed further, student. These are also some of the questions which we are giving. Write the IUPAC name. Write the IUPAC names of these compound, students. Important questions have been given. Important questions have been given here. This will be bracket closed. So these are some of the questions which you can do as a homework, students. Now here you have to write the formula of the compounds. Write the formula of the compound, students. Homework. So we can try to write the formulas, which the rules which we have told you. Whatever rules we told you, student. Iron 3 nitrate. This is if I have taken this one, for example, what is amine NH3? How many are there? 6. Iron 3 means that it is a complex cation. Nitrate is an anion. And what is the oxidation state? 3, student. So what will be the formula then, student? How do we write? First you write the metal. Then you write NH3, student. How many are there? 6. 6 hexaamine, student. Now how many nitrate should I write? Because the oxidation number of iron, how much you want? Iron is in 3. So 3 means this is 0 charge. Therefore you should have, student, NO33. Got it? This is the formula of this compound. Therefore, students, we can write the formulas of these compounds. We have to learn all these things. That how do we write the formulas of the compound? Here, this is the cation and ammonium. Because ammonium is a cation, it will be written first. Tetrachlorocuprate. Tetrachlorocuprate. Copper is in 2 oxidation state. Copper is in 2 oxidation state. That means it is CuCl4, student. So tetrachlorocuprate, but you have to satisfy the copper 2. Copper 2, how will we do copper? Because ammonium is present there. So how many ammoniums should be there, student? NH4 twice. Because cation comes first, anion comes later. This is a cation, this is an anion. This will be negative, this will be positive. See, this is the way we write the formulas. So we have learned already, students. These are some of the questions which we are trying to solve for you. We should know how to write the formula. 2 things we have done. And second, how to name the coordination compounds. This we must learn, students. Okay? This we have done. Okay? Any doubts here? Now some homework has been given. So you can try homework, students. We are coming to the next important topic. Questions are going to be asked on this, students. Questions are going to be asked on this. Very important topic is coming on the screen, student. Isomerism. Isomerism, student. There will be questions on this in the paper. Every year questions are coming. What is the meaning of isomers, student, in chemistry? You have been told isomers in organic chemistry. You learned it so well. They have the same molecular formula, student, but different type of structures were there. They were called isomers. These compounds were called isomers, students. Same chemical formula. When I say isomer, mean you are saying same chemical formula. But different, what is the difference? Different arrangement of atoms. Different arrangement of atoms is there, student. The arrangement of atoms will be different. So if the arrangement of atom changes, what happens, students? What will happen? Their physical properties will become different, right? So the result of this will be their physical or chemical properties will become different. Physical or chemical properties will become Different student. You know, their colors, their melting point, their dipole moment, everything can be different. Everything can be different. So important, there are two types of isomerisms which we will study in this. How many types? I'm saying two types of isomerism I will be studying in this case, student. Two types of isomerism. What are those two types of isomerism I will study in this case, student? One is called stereoisomerism. Other is called structural isomerism. You have seen stereoisomers, student? Stereoisomers, student. You have studied in organic chemistry. Tell me yes or no. You have studied optical active compounds, mirror image isomers. We discussed that in organic chemistry. What is that? How they are formed, students? Stereoisomer. Stereoisomers will be formed, students, when the arrangement of the chemical bonds or there is a different spatial arrangement. They have the same chemical formula, same chemical formula, students, same, but different arrangement, ठीक है, different spatial arrangement. Spatial arrangement means what, student? Different spatial arrangement, student. The in space, students, the atoms or groups are arranged in a different way. In a different way. So formula is same, but the arrangement is different. That means chemical formula, they have same chemical formula, they have the same chemical bonds, same chemical bonds, students, but arrangement is different. This is my important point. Spatial arrangement is different. So students, what type of stereoisomers will be there? Here I have written two. One I am saying, how many I have written here, students? Geometrical and optical isomers. We are going to study these two, geometrical isomers and optical isomers. Important question are coming in this stereoisomers. And you are saying they have the same chemical bonds, but spatial arrangement is different, students. Let us see what are these geometrical isomers. Okay. So we are going to tell you what are these geometric isomers, students. We are saying two or more than two coordination compounds which contain same number and type of atoms. They have same number and type of atoms and bonds. The connectivity between atoms is the same, but different spatial arrangement of the atoms. That means in space, student, their arrangement will become different. And there are two types of this, student, geometrical isomers, which we will experience. One is called the cis isomer, cis. Other is called the trans isomer. This we will study, student, cis and trans. What is the difference? Arrangement of atoms in space is different. Their physical properties, chemical property can become different because the atoms are arranged differently. So what we are trying to say, student, here you have this metal. Okay? If you have a metal, student, and supposing there are four coordination number, what the coordination number you are experiencing? In the polyhedra, I told you, student, coordination number what? 4 and 6 mainly in these compounds. 4 and 6. Ligand, how many ligands? 4. Or how many ligands? 6. 4 ligands, what shape can be there? Tetrahedral or square planar. If there are 4 ligands. How many? If there are 4 ligands, what shape you are giving, student? If I say ML4, student, it means there are 4 ligands. And the metal, this can be what shape? ML4. When I, if I say I am writing ML4 student, you are saying tetrahedral shape or square planar shape. Is it right? Tell me. You have been told earlier. So tetrahedral or square planar, two possibilities are there, student, in this case. And let us see what isomers are going to be there. I'm considering that shape is square planar. When it is tetrahedral, student, there will be no isomers possible because as the relative position will remain the same. It is a three-dimensional figure, tetrahedral. So isomers will exist in four ligand case in the case of square planar compound. Students, square planar. First, let me consider this will be possible only if you have heteroleptic complex. What is a heteroleptic complex? I told you. Two types of complexes I told you, students. Homoleptic and heteroleptic. Homoleptic means they have the only one donor ligands. Same donor ligand, only one type of donor ligand. Hetero means there will be two different donor ligands. Supposing I have L3X, that means X is different, L is different. In this case, we know no geometrical isomers are possible. No geometrical isomers possible. You can try to write down how, because if it is square planar, if it is square planar, student, I'm saying square planar. What will happen? Square planar, you know, this is square planar. You put X, 3X or 3L. There are 3L. Okay, let me put 3L. If I put student 3L, put anywhere and you put X, how does it matter? You can put X anywhere. They are the same compounds. Relative position is not changing, student. X put here, 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 no makes no difference. No geometrical isomer. But when I say ML2 X2 student, now there will be two isomers. These are heteroleptic. This is a heteroleptic complex and two ligands are different. Two ligands are different, students. X2. For example, student, now I am talking of this. I am given an example. Ma2B2 means this is my A, this is my B. Ma2B2. If I have students something like what we are writing here, Ma2B2 student, there means there are two A ligands, two B ligands. A2B2, what are A and B? A and B are ligands. A and B are ligands, students. There are two possibilities now. There are two isomers. How many isomers I can write? I am talking of geometrical isomers, students. How many isomers I can write? One is when the two same groups are adjacent. And one when the two same groups are opposite, student, across. Two identical groups, I'm saying two identical groups occupying adjacent position. That is called cis isomer. Cis isomer. When two arranged opposite to one another, that is called a trans isomer. So there are two possibilities, cis and trans. What are those? For example, this is my M. You see here, this is my A and B. These two same groups, student, identical groups, A and A, they are identical. And identical groups are adjacent to each other. Adjacent to each other. Do you see that? Adjacent. Similarly, B and B, they are adjacent to each other. This is called student the cis isomer. This is my cis isomer. What is this? Cis isomer. Or the easiest way to write is easier. Supposing I have this. You draw the square planar. You have A and A, they are adjacent, then B, B. This is cis. Or you, even if I write like this, they are the same thing, student. See, same thing. Adjacent, they are adjacent. But these are all cis. They are the same things. But if I have to write the trans, what I do? A and A across, student, B and B across. They are opposite to each other. Can you see they are opposite to each other? Tell me, this becomes trans. So there will be two isomer. One is called the cis, students, other is called the trans isomers. So here we have drawn, this is my trans student. You see they are across. The same groups are across, student. Same groups, identical groups are adjacent to each other, and identical groups are opposite to each other. These are identical groups are student opposite to each other. Clear? For example, student, now I say we have a PTNH3 2 Cl2 complex. These two ligands are, this is a heterolytic complex. This is what type of this? M is platinum, Ma2B2. I say write the geometrical isomers. Question. Question now. You have 1 minute. You have 1 minute to answer this question. How will you write the geometrical isomer, student, in such cases? Write the geometrical isomer. You have 1 minute to answer the question. When you will complete it, you will let me know you have done it. Students, if you do it, tell me. You have to write the geometrical isomers of this. How many will be there? One will be cis, other will be trans. Then how do I write? This is a square planar, student. Square planar. ठीक है? Platinum. The cis, I told you, how do I write the cis? Put the adjacent group on the same side. You can put NH3, NH3, student. You have Cl and Cl. What is this? Adjacent group on the same side. This is a cis form. And student, if I want the trans, same group opposite to each other, across each other, then I say, okay, NH3, NH3. Cl, Cl. See that what will be this? Cl, Cl opposite to each other, NH3 opposite to each other, this will be the trans. So students, you are getting two compounds, one is cis and other is trans. Their properties will be different, students. You see what is happening to dipole moment. Cl is more electronegative. This dipole is oriented on this direction. This is this. And here the dipoles are cancelling out, student. See the dipoles cancelling. So what will be the result? This will have a dipole moment. This will have a zero dipole moment. Is it right? Tell me. Right? This will have a definite dipole moment. This will cancel out. Equal opposite dipoles will cancel out, students. So their melting points are going to be different. Properties are going to be different. So what we are saying, student, this is the geometrical isomers when there are four ligands. The geometry will be square planar, students, square planar. For example, what was found, student? This complex, student, cis platinum NH3Cl2, which I have written just now. Thus, this is called cisplatin. Cisplatin is an anti-cancer drug, student. What is that formula? You have already been told. Adjacent group you have to write on the same side. Write Cl, Cl, okay. NH3, NH3. This is my cis form. This is my cis. This is a cisplatin student. This isomer is anti-cancer, is used to treat cancer student. It is called cisplatin. This is called cisplatin student and is anti-cancer drug. Cisplatin is anti-cancer student, anti-cancer drug. Interesting. And the trans is very toxic and poisonous. The trans isomer of this is poisonous. What is the trans? Square planar, opposite, same groups NH3 opposite to each other, Cl. This is a trans isomer. This is toxic student. Is a poison. Is a poison. See the difference in biological application. Coordination compounds, I will tell you, have strong biological application students. They are working in our body. They are used to remove lead, poisons, poisonous substances from our body. They have very wide applications. We will show you. That's why we are studying it. Coordination compounds are very important student. Chlorophyll is a coordination complex of magnesium. Chlorophyll. Hemoglobin is a coordination complex student, chelate complex of iron. Heme. You have bio, then you know already heme. They are coordination compounds. Supposing student, a question is given. If he says, will it have geometrical isomers? This is a ethylene diamine bidentate ligand. Coordination number, what is the coordination number here, student? If I say PTEN22 plus, you know already what is EN. It is a bidentate ligand student. And you know what is the formula? CH2NH2, CH2NH2 student. This has two teeths. And it forms a ring student. It forms a chelate ring around the central metal atom. Here we have platinum. Can I write the isomers of this? Yes or no? Yes or no? That's all. Can it have cis or trans or no? That is the question. This complex, you know, if I write square planar, what it will look like? How it will look like, students? I have platinum. How the short form of this? How do I write the short form? En. Another En student. This is the short form of this. Can it have a geometrical isomer? Tell me. If you want to see it like this, student, it was something like this. Here is En. There is only one possible structure. I can't write anything more than that. Only one possible structure, student. It does not show any geometrical isomers. It does not show, question are going to be there in the paper, does not show geometrical isomers, students. Clear? You have noted down? I will proceed further. Now he says, draw the cis and trans isomers of the following compounds. How will I draw, student? Here, IR, iridium. You have NH3, this is a coordination complex, student. NH3 two times. And you have Cl and CO as ligands. How many? These are the ligands. These are the ligands. These are the two ligands are same. We already told you, if I put the same ligands adjacent to each other, student, then what is left? Cl and CO. And if I put these two ligands opposite to each other, how they will look? And H3 and H3 student opposite to each other. And then what you are left is Cl and Cl. So there are two forms. This will be our cis and this will be my trans. Clear, students? In the exam, student, he can give different ligands. It's not necessary every time he will give the same ligand. So this case is like Ma2 BC, Ma2BC. There are three types of ligands. Three types of ligands. He says draw for this. If I have to draw for this student, draw for this. Here, this pH3, they are two students. What is the formula? P, you know that this is a bis. We have already told you try pH3 twice student. Phosphine, and platinum HBr. These are different. This is the same ligand. So what we can do? Platinum, when you put adjacent to each other, pH3, pH3 student. Let me, so that there is no mistake. What is this group? pH3 students, pH3. And what is left? H and Br. Put it here or there makes no difference because they are the same. This is cis. And you want to write the trans, what will you do? You make these two opposite, pH3 and pH3. Across each other, what is left then? H or Br. Makes no difference. Put anywhere, this is the trans. So this is how we write cis and trans isomers. Compound, any compound can be given to me in the exam. Draw the cis and trans. They will have different physical or chemical properties. I hope you have understood it, student. Then we proceed further. In octahedral complex, in octahedral, how many ligands are there? 6 ligands. There will be 6 ligands. Octahedral means there are 6 ligands. This will have octahedral shape, student. Here, cis and trans is possible when you have complexes like Ma4B2, student. Means these two ligands are same and these 4 ligands are same. These are all examples of heteroleptic complexes. We have told you what are heteroleptic complexes, student. At least two different donor atoms. Heteroleptic. Okay, how will we write if I have something like this? What is the best way? What I will do? Octahedral, you know what is octahedral shape. This is my octahedral. Ligand. I will put the same ones. This I put the same B2 like this. Rest are A. You got it? If I join this is octahedral. Can you see the octahedral, students? Identical groups are on the same side. This is my cis isomer, student. And if you want trans, you make them opposite. That is the only thing. Easiest way in exam. I put B here. I put B here. They are opposite. Rest is A. See, these are opposite. These are identical. This will become trans. So that this B2 student you will use for making cis and trans isomers. Clear? Any doubt? Can you make it, students? Okay. Example we are giving student. He says draw the cis and trans isomers. You are given CONH3 4Cl2 plus. He says draw the geometrical isomers. You have to draw the geometrical isomer, students, of this compound. How will I draw, student? I told you a very simple thing. What I will do in exam, student, you already know what is octahedral, something like this. You are aware of this bond, student. This is square planar and like that. I will put Cl. There are two Cl. I put Cl here and Cl. Then rest 4 I will put ammonia. NH3, 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 student. There is a +1. I am showing it like that. So this 2 Cl on the same side is my cis. And then I put Cl opposite to each other, students. Opposite to each other. Cl and Cl. Rest you put NH3. 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 Then this will be my trans isomer. So in octahedral complexes also student I can write cis and trans, cis and trans. Note it down students. Note it down geometrical isomers. Okay. Then I proceed further students. If you students, if you have some bidentate ligand, for example, COCl2En twice student. This En is a bidentate ligand student. En, you already know ethylene diamine student. The formula we have told you so many times. CH2, CH2, NH2. This is a bidentate ligand student. This nitrogen, two nitrogens will take part, act as a ligand and will form a ring around the central metal. Ring around the central metal. How will we draw these structures? Very easy. What I will do? CO again octahedral because coordination number is how much here? Coordination number is how much? This is 2 into 2, 4 plus 2, 6. Coordination number is 6 student. Then that is octahedral. You already know. We have already told you student when coordination number 6 octahedral, coordination number 4 square planar or tetrahedral. But tetrahedral does not form geometrical isomers. Then here what will I do student? We are aware of student how we draw the structures of these. See, this is my octahedral. Now you have 2 En. If I put 2 Cl here, student, on the same side, what is left? En. This is a bidentate ligand. I am showing it like this. Because there are 2 nitrogens, as you can see, bidentate ligand. Bidentate ligand. So 2 atoms are going to bond with the cobalt in each ethylene diamine. That is right or wrong? Tell me. So this is the Cl on the same side. This is my cis isomer. And for trans is more easy, student. Trans will be more easy. How will I write trans? Let me write the trans student now. Trans is more easy. In such cases, you write cobalt and you are aware of what is the shape of the octahedral. I put 6 line like this, octahedral. Now, if I put these En opposite to each other, then what is left? Cl and Cl. You can see this is a trans isomer. Trans opposite groups are across each other. What is trans? Opposite groups are across each other. Identical groups are on the same side. That is the definition I told you about cis and trans. So whenever we want to draw cis and trans students, in such cases, we will draw like this. We'll draw like this. Any doubt? You can ask me, students. If you have any doubt, you can ask me. What I am talking is geometrical isomers, cis and trans. So in coordination number 4 and in coordination number 6 students. This is example of coordination number 6. One important case which was asked in the paper is student, when you have Ma3B3 type of situation. This is going to be a special type of geometrical isomers. In octahedral student, in octahedral complexes, in octahedral coordination compounds, students, we are having such compounds in which Ma3B3 student. These are the 3 same groups, 2 donor ligands, but 3 of each, and they show student a special type of isomerism which is called student geometrical isomerism, which is called facial and meridional isomers. They important point, very important. They show student one is called facial or FAC isomer. FAC. And the second isomer is called, student, this has been asked in the paper, important. Second is called meridional, student. Meridional or mer isomer. Mer isomer, student. Now, how will we write these isomers, students? Important. In the exam, he will ask you, draw the FAC and mer isomer of such complexes. What I will do, student, for example, this is my metal. This is my metal. How the octahedral looks like, student? This is the octahedral. If I put the three same groups like this, A, student, and put B, B here. What you can see, student? Interesting. What do you see here? If I, student, you see that if I join this line, you see a triangle. And similarly, if you join these lines, you see another triangle. See that? And this is called FAC, student. This is called a FAC isomer. FAC is basically the cis form. FAC is basically the cis form, students. Now, if I want to write the mer form, this is my FAC form, facial. If I want to write the mer form, what I will do, students? What I will do? Here, three groups were same, student. I will change, student, one of the groups. I will change one of the groups. How will I change? In an easiest way, student? So that I remember in the paper, student. I have M, again I write like octahedral. You can draw an octahedral, student. Now, what is the happening, student? In this case, you had these three groups were on this side, student. A. What I will do? I am going to shift them, student. You shift these groups now. Where will you shift, student? In these two groups. What I am doing, that you have A here. You have A here, student. You put this A on the other side. On the other side. What is, I'm changing this position now. This A is still retained. I'm putting this on the other side. And then I put the other groups which are B here. B, and I put student A here. This is called the mer isomer, student. Mer isomer. So there are two isomers. One is FAC and other is mer. Is called meridional. It is called facial, student. Question was given, write the FAC and meridional isomers of these. Cis or trans? This is called trans, student. This is a cis form of it. Same groups are on the same side. So here is the FAC form, student. 3NO2, 3NS3 on the same side. And if I change, students, this I bring it here. And then this one I change, then rest of these I put, then I get mer. So FAC and mer isomers are very important, students, in exam. Special type of isomerism. What is this? CONH3, student, 3NO2, 3. So for this we are drawing two isomers, geometrical isomers. They are geometrical isomers. One is FAC, other is cis. Can you see it? And here is another complex, student, which has got CO, and you can see COCl3, CN3, students. And what are the mer and FAC isomer, student? See the mer isomer and FAC isomer, you see same group on the same side, triangle. And then what I am doing, change one of this. This is still retained. I am putting one here. Change them, student. Then what happens? What will I get? So you will get two isomer, students, two isomer. One will be FAC, another will be mer isomer. By changing the positions of the group, by changing the positions of the group, students. You see here 3Cl in one plane, here Cn and Cl and Cl. Change the position. So there are two isomer, mer and FAC, students. This is a cis form and this is the trans form of this. So you have seen what I have talked is geometrical isomers. A question was given in the paper. Why is it question? Why is geometrical isomer not possible in tetrahedral complexes having two different types of unidentate ligands coordinated with central metal atom? What is our answer, student? Why tetrahedral do not show geometrical isomers? Because students, because the relative position, student, the relative position of the unidentate ligands, relative position of unidentate ligands attached to central metal, attached to the central metal atom are same. Relative position remains the same, student, because same with respect to each other. Because it is tetrahedral. You know what is tetrahedral shape? Already you know. You have M and you have X and other is Y supposing. This is a tetrahedral, student. Bond angle, you know how much is that? All bond angles 109.5 degree, three-dimensional. So how does it matter, student? You can put X or Y anywhere. Relative positions doesn't change. Relative position of the atom doesn't change, student. Therefore, it does not show. Therefore, tetrahedral complexes do not show geometrical isomers. Okay? Is it clear, students? So this was about the geometrical isomers. And we will continue more in the next class, students, where we will discuss more about isomerism. Important questions are coming in the paper. So we will see you tomorrow at 12. Tomorrow at 12 for more questions further about different type of isomers which exist in coordination compound, because questions will be asked on isomerism is very important for exam. All these are important questions which we are discussing. Okay, good night. I will meet you in the next class. Okay.